Let's set the scene. You're standing in a remote place, far from city lights, somewhere near the Arctic Circle. The air is crisp, the sky is an inky black, and suddenly, there it is. A swirl of vibrant greens, pinks, and purples dances across the sky like a celestial ballet. The Northern Lights. For centuries, these lights have fascinated people, sparking myths and legends across cultures. But today, we're going to explore something even more interesting than the legends. We're going to uncover what really causes the Northern and Southern Lights. To begin our journey, let's start with a bit of a scientific background. Don't worry, it's not as complicated as it sounds. We're going to break this down step by step, starting right where it all begins, with our star, the sun, the solar wind, the sun's fiery breath. So here's the thing about the sun. It's not just a giant ball of fire lighting up the sky. It's also constantly sending out charged particles in every direction. And this stream of particles is called the solar wind. Think of it as the sun's fiery breath, except instead of air, it's a bunch of tiny charged bits of matter, mostly electrons and protons, zipping through space at incredible speeds. Now, most of the time, we don't even notice this solar wind. Earth has something very special that keeps us safe from it, our magnetosphere. The Earth's core generates a magnetic field which extends far out into space, creating a kind of invisible shield around the planet. This magnetic shield is what keeps most of those harmful solar particles from reaching us. But here's the twist. Sometimes, under just the right conditions, some of those particles sneak through. Magnetic fields, the cosmic shield. All right, let's break this down. The Earth's magnetic field works kind of like a donut. If you could see it, it would look like big loops of magnetic energy stretching out from the North Pole and the South Pole, wrapping around the planet. Now, remember those charged particles from the sun? When they hit Earth's magnetic field, they're deflected toward the poles, where the magnetic field is strongest. This is where the magic happens. When the solar wind interacts with the Earth's magnetosphere, it starts to squeeze and stretch it, kind of like pulling on a rubber band. This interaction creates energy, and that energy is released into the Earth's upper atmosphere near the poles. Now, imagine those charged particles zooming along Earth's magnetic field lines, heading straight toward the North and South poles. When they finally reach the upper atmosphere, boom! They collide with atoms and molecules up there, and this collision is what gives birth to the Northern and Southern Lights. Lighting up the sky, the science behind the glow. So, here's the deal. When those charged solar particles hit the atoms and molecules in Earth's atmosphere, they transfer their energy. This makes the atoms excited, kind of like when you're so full of energy, you just have to move. In this case, the atoms release that energy as light. Different gases in the atmosphere produce different colors when they're excited. Most of the time, we see green lights. This happens when the solar particles collide with oxygen about 60 miles up. But if the particles are higher, say around 200 miles, oxygen can produce a red glow. Nitrogen, on the other hand, tends to produce purples and blues. And that's why, depending on where you are and the strength of the solar wind, you'll see different colors swirling across the sky. Northern versus Southern Lights. What's the difference? Now let's clear up a common question. You've probably heard of the Northern Lights, also called the aurora borealis. But what about the Southern Lights, also known as the aurora australis? Are they the same thing? Spoiler alert, yes they are. The only real difference between the two is location. The Northern Lights happen near the North Pole, while the Southern Lights occur near the South Pole. Both phenomena are caused by the same process: charged particles from the sun interacting with Earth's magnetic field and atmosphere. So, if you've seen one, you can imagine what the other looks like. Solar storms, when the lights get wild. While the auroras are always there, just waiting to happen, they can get super intense during certain solar events. Sometimes the sun has what we call solar storms, which are like massive explosions of energy on the sun's surface. These storms release huge amounts of charged particles into space, and if Earth happens to be in the way, we get a much stronger solar wind. When that happens, the northern and southern lights go into overdrive. Instead of the usual gentle ribbons of light, you can get a full-blown light show that covers the sky, even reaching areas much farther from the poles. Imagine seeing the aurora in places like Scotland, Canada, or even as far south as the United States. That's what can happen during a big solar storm. The impact of auroras on Earth. It's not just pretty lights. Here's something you might not know. The auroras aren't just about looking pretty. These light displays can actually have real effects on our technology. Remember all those charged particles from the solar wind? Well, during a strong solar storm, they can interfere with things like satellite communications, GPS, and even power grids. In fact, in 1989, a huge solar storm caused a major blackout in Quebec, Canada, knocking out power for millions of people. So while the lights in the sky are beautiful, they can also be a reminder of the immense power of our sun. Chasing the aurora. Where and when to see them. So, where can you see these magical light shows for yourself? The northern lights are best viewed in places close to the Arctic Circle, like Norway, Sweden, Finland, Iceland, Canada, and Alaska. For the southern lights, you'll want to head to places like Antarctica, New Zealand, or Tasmania. The best time to see the auroras is during winter, when the nights are long and dark. And while the lights can technically happen at any time, they're more common during periods of high solar activity, like during solar maximums, times when the sun is more active and releasing more solar wind. But here's the catch: the auroras are notoriously unpredictable. You can plan a trip to the Arctic in the dead of winter during peak solar activity and still not see the lights. Or you could just be going about your business in Iceland and catch an incredible display without even trying. That's part of their mystery, part of what makes them so magical. The cultural legends of the lights. Now that we've explored the science, let's take a moment to appreciate the cultural side of things. Before we had any idea what was really going on up there, people across the world came up with some pretty fascinating stories to explain the lights. In Norse mythology, for example, the northern lights were thought to be the flickering armor of the Valkyries, warrior women who decided the fate of those who died in battle. The Inuit people of North America believed the lights were spirits of their ancestors playing a game, perhaps a version of football or soccer, with a walrus skull. In some Scandinavian cultures, the northern lights were believed to be a sign of impending war or disaster. Meanwhile, the Maori people of New Zealand saw the southern lights as reflections of campfires or torches in the sky, belonging to the ancestors. These stories, while rooted in ancient beliefs, all capture the same sense of awe and wonder that we still feel today when we see the auroras. The science still unfolding. Even though we know a lot more about the northern and southern lights today than our ancestors did, the truth is, scientists are still learning about them. There are still questions about how exactly the particles from the sun interact with Earth's magnetic field, and new discoveries are being made all the time. For instance, in 2016, scientists discovered a new type of aurora that they nicknamed STEVE. Unlike traditional auroras, which are caused by electrons, STEVE is thought to be caused by different kinds of energetic particles. Instead of the usual greens and purples, STEVE appears as a narrow purplish-pink band of light, often with a green picket fence-like structure. It's just one example of how much we still have to learn about these mesmerizing phenomena. Wrapping up, more than just a light show. So what causes the northern and southern lights? It all comes down to a cosmic dance between the sun, Earth's magnetic field, and the particles that zip through space. It's a phenomenon that reminds us just how connected we are to the universe around us. The sun, millions of miles away, creates a light show on our planet that leaves us standing in the cold, staring up at the sky in wonder. But the auroras are more than just a pretty light show. They're a reminder of the incredible forces at work in the universe, forces that can affect our technology, inspire our myths, and remind us of the mysteries still waiting to be uncovered. So next time you find yourself beneath a shimmering aurora, remember, you're witnessing something far beyond just colors in the sky. You're seeing the universe at play in one of its most beautiful forms. And who knows? Maybe one day you'll find yourself chasing the auroras, standing in awe as the sky above you comes alive with light, knowing the incredible journey those particles took to put on that show just for you.